Hello, I'm excited to talk to you about sgrep today. The summary of this talk is that writing secure code is hard. We need better open source tools, and I'm going to demo that. But before I show you all that, let me tell you about myself. So I'm Drew. I'm the co-founder of R2C. We're a static analysis startup in SF. We're 15 people, and the work I'm going to show is a lot of hard work by many other people. Give you a quick overview of my talk. So I probably don't have to tell most of you that writing code is really hard to do it securely. But I was recently reading through the set cookie documentation in a popular Python web framework, and I was surprised to learn that the default was where secure equals false, HTTP only is false, and a newer one, same site is none. And I thought, okay, if I'm a developer, like I've written a lot of these things myself, I'm probably going to go find something on Stack Overflow, and I just want to set a cookie. The code's probably going to look like this. And my job as an AppSec engineer is to go through all the instances in the code base and find it. So how could I do that? Well, one of my favorite tools is using grep. My kind of first take at a grep regex is just to escape the dots, escape the parentheses, and just look for all calls to response.setCookie. And this is pretty good. It's certainly fast. Grep is really easy to learn. It works across almost every language. And I really like grep. But then I remember that there's many different ways to do the same thing in code. So you have the kind of naive, simple way of setting a cookie. But oftentimes, for convenience, you might import the methods, to type out the long string as just something like, say, from Flask response set cookie as SC. And then I'd have to write another regex, and then probably have some new false positives, because who knows what the person's actually named the function. Finally, there's this weird part in Python where you have these keyword arguments that basically let you define these things in any order. So that's also going to make it complex to match with regexes. And because I use a formatter when I write code, oftentimes this will be on multiple lines. And so, I might have a case that's actually secure, like here, but it's on multiple lines. And so that's just another false positive I have to look for. And finally, when I write code, oftentimes I'll comment out sections that I might come back to later. And as an AppSec engineer, I don't always want to see all the commented out code. So just to summarize, there's really four main categories. There's kind of the default way to write things. You can import and rename it. You can use keyword arguments. You have to think about multi-lines and commented out code. So if we run our regex, how do we do? Well, we get some hits and some misses. And by my count, we get 1 true positive, 3 false positives, and 1 false negative. I think we can do better than that. Usually, if you use regexes, you're probably just going to have another problem for yourself. So what's fundamentally the problem here with using grep is that code is not a string. Even though we all type it out in our editors as strings, to the computer, it's a tree. And every single line has semantic meaning that's important. So how do you typically solve this problem? There's things like linters and commercial off-the-shelf tooling in the Sass category. Some of you may have even tried to write a Flake8 or an ESLint plugin. One problem is you have to become an expert in the syntax for every language that your team uses. And commercial tools are great, and I really enjoyed Sid's talk earlier, but they can often be expensive or hard to tune. To give you an example, I was trying to search for some Bo2.3 credentials, and I had to write about 100 lines of a Flake8 plugin to match that. And honestly, I'm not even sure I got it right. What I actually care about is I want to find all the calls to Flask response set cookie with anything a developer has hit. I'm going to audit my code base for that. I need something that's not as simple as grep, but it's not as complex as a full Sass solution. Sgrep is somewhere in the middle. Sgrep brings the power of Sass with the combination of the ease of grep. You can brew install it, and as you would hope, the language you want to express to find that pattern that set cookie is simply flask.request.setCookie, and then the ellipsis operators ... It's that simple. Sgrep is free and open source licensed, and it came out of Facebook, and R2C hired the lead author last year. To get started, you can go to sgrep.dev as a short link that just redirects to our GitHub repo. And I'll post the slides. The slides are already posted, but I'll have a link at the end where you can see this, so don't worry about trying to write anything down right now. Let's actually see the tool in action. So I'm going to get started, and I'm just going to look for the simplest thing possible. Maybe I'm a Go shop, and I'm looking for cases where the developer has used listen and serve instead of listen and serve TLS, which is an easy mistake to make and one that I've made myself. I'm going to pop into our live editor. Sgrep is both a Mac binary and a Linux binary, as well as a Docker container. But for the purpose of the demo, it's often easier to use a website. And this website you can think of as very similar to regex 101. There's a lot going on here, and it's a pretty powerful tool. But just to give you the highlights, up here in the upper left, you're going to write a pattern that you're trying to search for. And then below it, we have the code that you're actually looking to search for. So in this case, I've pasted in a minimal example of a Golang web server. And what I want to do is I want to find all the places where someone's called HTTP, listen and serve. And I'm going to copy that in here and search for that. But I'm not sure that the developer is serving on port 80. In fact, they're probably serving on 443. And I don't know what other optimization arguments have been pushed. There may be some debugging flags or things like that. So again, the ellipsis operator just says, I don't care, find all calls. If I run that, you can see it instantly returns the call to that insecure web server. To give you a slightly more complex and maybe more security relevant demo, oftentimes SaaS tooling is used to find injection, where the user controls some data, say a file name, but then gets passed to a dangerous function. So in this case, send file. And I want to find calls like this. Let's see if we can use sgrep to find that. So again, I'll show you the code snippet. And this is, of course, a minimal example. But here I have a route handler that takes in a file name, it prints it out, and it sends back the file as an attachment. Pretty straightforward stuff, but it will show the power of how you do this. And I'll also introduce a new concept, which is variables. So the first thing I'm going to do is I'm going to walk through this line by line with you. I have a route decorator, so I'm only going to get these Flask route functions. I'm not going to get any random thing that's called get file name or any other sort of string-based matching. I don't know the name of the route the developer has chosen. So I'm just going to use ... to just say, ellipsis. I don't care what the characters are in this string. Just match any string here. I also don't know what the developer would choose to name the function. So let me just define a variable. I can do that by doing $ capital funct. And it doesn't really matter what it's named, just giving it a friendly name. And I'm going to do the same thing with a file name. So let's do $fn. And I don't care about any of these like logging or print statements. That's kind of just noise, in implementation specific. So again, I'll use the ellipsis operator to get rid of that. What I do care about is the fact that I have a Flask object that's calling send file, and I'm going to pass in the $fn variable that I defined above. And I don't, again, care what arguments are being passed, because that's sort of outside the scope of my code audit. And let's see if that works. Boom, we get the hit. So it just shows you how easy it is to look for common framework patterns that lead to real security bugs. And if you think back to that set cookie example, let's see how we'd solve it for real. And I'm going to go on to our third demo. So in this case, I'm going to introduce a YAML syntax. And we found this really helpful when you actually need to think about true positives and false positives and all the rest of those other great cases. So in this case, again, it's an example just like we had at the beginning. I have Flask, I'm importing response, I'm calling it as R. I've got the default case, just sort of how I might do it. I have a multi-line case with an inner function. I have some commented out code. And finally, I have the correct, secure, kind of best practice use case. So just get started. I'm just going to give this a friendly name so I can identify it in any of my integration tooling. I call this flask.say secure cookie. And then let's focus on what we don't want to match. So the first thing we don't want to match, this is the secure case, right? So I'm going to filter out all the good cases. Response.set cookie. And I don't know necessarily what the first few arguments are, but I do know that in that case, it has HTTP only equals true. And I'm going to go secure equals true. I can type. And I won't care about secure site for now because Google's not enforcing it thanks to COVID. And everything else we have is we'll say that's a security flaw. So let's just find all cases, everything else. I'm going to give it a friendly message and just be like, hey, cookies are hard. You could say contact security. You can interpolate variables. There's some advanced features there. But let's go ahead and run it. And one other subtle thing you might not notice is that in this case, I have secure equals true and HTTP only is true. But in my pattern, I have HTTP only as true and secure showing that the order won't matter. Boom, I get the two cases that are insecure, the default case and the multi-line case. I skip over this the comment because the program understands that's not part of the code that actually gets run. And I correctly don't flag the secure use case. It's that simple. Now that we know about variables, let's have some fun. So here's a really simple case, but would a developer ever make a mistake where they have a variable equal to itself? That's naively always true. And it seems kind of hard to believe that someone would make a mistake like that. But if we jump into the code editor, I already pre-filled this one out for you, but you can see the pattern is super simple. It's $X, meaning anything, any code snippet, any function of characters. It can be like x plus 3 is also equal to x plus 3. Any basically anything, and we'll just abstract away that code pattern and say, does that equal anything else? And in this case, of course, it trivially matches. But let's run it over some real code. So I think the Apache libcloud is an interesting project. I might use that myself. Let's go ahead and scan that. Take just a second as it queues up, and boom, we have one finding. Let's go take a look. Surprisingly, inside the compute drivers for Cloud Sigma, there's what appears to be a bug. Let's verify that's true. And I think this doesn't actually do what it says. My understanding through reading through the 2,000 lines of code is that this is supposed to return a single node, and you're going to identify it with a node ID. But here, it looks like maybe the developer's editors auto-completed or something. They have node.id equals node.id. It will return the entire list of nodes. And so I'm going to go make a PR after this where I replace node.id with node_id. And that's an example of just a simple bug that's really easy to find. All right, getting back to the presentation. So now that you've seen how easy it is to write a rule, we started quickly writing a lot of rules, and our friends did too. And we said, hey, how do we collaborate on this together? And so I'm going to talk to you about our registry, and caveat, this is still beta, and a lot of things are changing quickly, and we'd love more input from the community. But let's talk about the community rule registry. So once you've installed sgrep with brew, you can just run --config equals R2C, and that's just a short link for our community registry. That is, our sgrep rules repo. You can use this with any Git repo, so you can have your own private registry if you want, but the power really comes from the fact that we have amazing community participation. We're just getting started, but already one of the leading tool authors for JavaScript has ported 95% of his rules to sgrep and has given us amazing feedback. So we're really excited about the community participation, and together we can help secure code by sharing these patterns and best practices. Just to give you an example of a pattern that I would never have thought of, I know JWT tokens are scary and you can sometimes have none algorithms, but somebody who's an expert in JWT tokens wrote all these different edge cases and ways you can set the algorithm to none. And I can just run that immediately today and get value on my code base. One other benefit of the registry is by having this collection of rules, something we at R2C built is we've built this giant MapReduce system that lets us run all these rules over hundreds of thousands of real Git repos every single day. And so that simple $x equals $x actually gets a lot more complex as you start to run it over real code, because you realize that developers often will put this in test code as a way of kind of commenting out a lot of tests cheaply. It's not maybe the best practice, but it's how people actually write code. And this lets us carefully monitor and tune and improve rules on real data. And just to give you an example of this tuned rule, it went and found some real bugs in various popular open source projects. Next, you're probably wondering, how can I actually use sgrep? So let's talk about integrations for just a second. You can find bugs in code, which we just did, but we're AppSec engineers. And so what we want to do is we want to find insecure defaults. We want to enforce those. We want to write better frameworks that have easier ways for the security team to inspect and monitor things. And we want to do this at CI time. So sgrep is super easy to add to any CI system. We have both an official Docker image and a Linux binary published. And yes, we have JSON output. We've got started by just writing a circle CI config and a GitHub action. Talk to me if you'd love more details. A lot of things are changing there rapidly. Features on our roadmap over the next quarter or two. So we're working on more code equivalences in most languages. $x plus y is equivalent to them swapped, but not all languages. We're working on integrating external type information, since languages like Ruby and Python and JavaScript now have great external typers. And then we're working on making more robust our tainting information. that, I'd love to take any questions. Thank you so much for letting me introduce sgrep. I hope you go try it out. You can use the live editor. That's open to anybody. You don't have to sign in. And you can also just install our brew and run it with Docker. We have a built binary that works for Ubuntu 16.04, and we are working on a D package and maybe a snap package as well. So yes, it's coming. Just got started with brew. Yes, you could look at our roadmap on it's sgrep.dev on our repo. Probably the ones that are next are Ruby, maybe Scala, support for C++, Java. But really, we've been able to add languages really quickly, and we're working on using TreeSitter, which is a framework that lets us basically add 30 languages at once. So more languages support is coming very fast. But we focus on Python, JavaScript, Golang, and Java just to get started, because those are the languages that we find ourselves using a lot. Thanks so much, everyone.